Hey guys, my name is Shreyas and welcome to Simple Chemistry. For the next few videos, we're going to be talking about significant digits. In this video, we're going to just have a brief introduction so you understand what significant digits are. So significant digits are, why are they used? Scientists use significant digits to indicate the accuracy of a measurement. Okay, so let's say we wanted to measure this line right here. So we don't know the exact length of this line. We can't be like, okay, we know it's 5.2347763. We don't know. Okay, there's only a degree to which we are certain. We can probably estimate this to be something like 5.5 or 5.6. That's all we can do. We can't estimate past that. So scientists use significant digits to basically have this indicate the accuracy of a measurement. Basically say how accurate we know it is. So it's very important. Okay, so there's 4 rules on significant digits. So basically, what you have to do with significant digits is that, 1, you have to know how many significant digits a measurement has, and these are the 4 rules. And 2, you're going to have to be using these significant digit rules in all your calculations within chemistry. Okay? So it's very important to you understand. So in this video, we're just going to be kind of focusing on, if you have a number, how do we know the number of significant digits that number has? Because that's very important to know. You're going to get that as we keep going. So the first rule is all non-zero digits are significant. So if you look at this number here, 13,479, every single digit here is non-significant. I mean, is not zero, right? None of these digits are zeros. So because of that, this number would have 1, 2, 3, 4, 5 significant digits. Now, when you talk about zeros, this is when it starts to get complicated. So second rule is hug zeros. So these are zeros between other significant digits are significant. So you can see here the 2 zeros here are between 4 and 2. We already know 4 and 2 are significant because all non-zero digits are significant. And they're kind of hugged, right? Because they're in between these other significant digits. So these zeros also become significant. Okay, so that would mean that 4.002 has 4 significant digits. 4 and the 2 hugged zeros, making it them also significant. Third rule is leading zeros, which are zeros in front of non-zero digits, are not significant. So if you look here, we have zeros in front of non-zero digits, right? These are all in the front, all to the left of these non-zero digits. Because of that, these zeros are not significant. So when you're talking about this number here, we'd say that only the 3 and the 7 are significant. This number only has 2 significant digits. Trailing zeros, which are zeros that are after non-zero digits, so that's zeros to the right, are significant only if they are to the right of the decimal point. So if you look here, you have 107 and then you have a 0. The 0 is a trailing 0 because it's coming after after the non-zero digit, which is 7. However, it's not to the right of the decimal point. The decimal point is right here. So it's to the left of the decimal point, so it's not significant, the 0 right here. So this number only has 3 significant digits. 1 is 7 because of the first rule, and then this 0 because it's a hugged 0. In this case here, the trailing zeros here are significant because they're to the right of the decimal point. Okay, look here. This 0 here is to the right of the decimal point. And because of that, it is significant. The 1, the 0, and the 7. It's 1, 7 are significant because of the first rule. The 0 is significant because of hug zeros. And now, since this trailing 0 is significant and this 7 is significant, the second rule here is saying that zeros between other significant digits are significant and make the 0 here also significant. So this number here has 5 significant digits. Okay, so those are the 4 rules. Let's go ahead and do some practice. Okay. We'll start with this. So this number here has, this 2 is significant because it's a non-zero digit according to our first rule here. However, these 2 zeros are leading zeros. Leading zeros are zeros in front of non-zero digits, and these numbers are in front of the non-zero digit here. So this number only has one significant digit, and that's just the 2. Okay, in this case here, the 2 is significant because it's a non-zero digit. These are, just like here, leading zeros, these 2 zeros, so they're not significant. This is a trailing 0, and it is to the right of the decimal point, so it's also significant. So this number has 2 significant digits. Okay, here. The 5 and the 1 are significant because they're non-zero digits. The 0 is in between 2 significant digits, so it's a hugged 0, and so that's the reason why this is also significant, the 0. So that means this number has 3 significant digits. Here, same thing, the 5 and the 1 are significant because they're non-zero digits. The 0 is significant because it's a hugged 0. This 0 here is a trailing 0, and since it's to the right of the decimal point, it's also significant, making all 4 digits significant. Here, we have a non-zero number, the 5, so it's significant. These are trailing zeros, but they're not to the right of the decimal point. The decimal point would be right here. So it's to the left of the decimal point, these numbers. So these zeros are not significant, so this number it has only 1 significant digit. Now here, the 5 is significant. This 0 is trailing. Let's get back to that. These zeros here are trailing. They're all to the right of the decimal point. So these zeros automatically all become significant. And because this 0 here is between 5, which is a significant digit, and this 0 here, which is significant because it's a trailing 0 to the right of the decimal point, this 0 becomes a hugged 0 because it's between 2 significant digits, and this 0 is also significant. So this number has 1, 2, 3, 4, 5 significant digits. Here we have 6, 5, 1. They're all non-zero digits, so they're significant. This 0 here is a hugged 0, so it's also significant. It's between 2 significant digits. These 2 zeros are zeros to the right of the decimal point. They're leading 0. They're trailing zeros, and they're to the right of the decimal point, so they also become significant. This number, therefore, has 6 significant digits. Here, we have the 5, and that 5 is significant because it's a non-zero digit. These zeros in front of the 5 are all leading zeros. Leading zeros are not significant because they're all to the left of this number here, so that would make this number only have 1 significant digit, the 5. Here, the 1 and the 2 are significant because they're non-zero digits. The 0 here is a hugged 0 because it is between 2 significant digits. The 0 here is a trailing 0 to the right of the decimal point, so that also makes it significant. And then this 0 here is a leading 0, and so that's not significant. So these digits here are the only significant digits, so this number has 4 significant digits. Here we have the 1 and the 1 here, non-zero digits, so they're significant. These zeros here are trailing zeros to the right of the decimal point. Well, actually, I guess there's 2 rules here that you can go with. The hugged 0 rule, because these zeros are all between significant digits, these 2 significant digits here, it makes all 3 of these digits significant. Let's just say that's the explanation why. That's the correct explanation. Okay. Here, kind of same case, these 1, 2, and 1 and 2 are all significant because they're non-zero digits. These zeros here are significant because they're hugged zeros. They're between 2 significant digits, the 2 and the 1. And then the 0 here is a trailing 0 that is to the right of the decimal point, so that makes this significant. So this number will have 7 significant digits. Finally here, the 1, 1, and the 1 here are all significant because they're non-zero digits. The 0 here is a hugged 0 because it's between 2 significant digits, the 1 and the 1 here. And then these zeros are all leading zeros, so they're not significant. So only these 4 digits are significant, making this number only have 4 significant digits. Okay? Now, exact numbers are numbers which have an infinite number of significant digits. Okay? So, let me give you an example here. We know for a fact that in 1 meter, there are 1,000 milliliters. There's no there's no discrepancy between that information there. We know that for uh, within 1 meter there's exactly 1,000 milliliters. Sorry, 1 meter there's exactly 1,000 millimeters, and we don't use significant digits in that case because we know that's exact. There's not 1,000. It's not an estimate. Okay. Also, numbers which are counted. So, example, let's say you have 7 apples. Those numbers have an infinite number of significant digits because we counted them and we know for a fact there are 7 apples. And those numbers also have a infinite number of significant digits. Okay, that's all we have to know for significant digits now. In next videos, we're going to be looking at significant digits and how we use arithmetic with them. But that's it for now. Significant digits are as simple as that.